today. So we're going to look at one of the applications of trigonometry, which is bearings. That's one of the main applications. The other application will be angles of elevation and depression. So bearings are usually measured from north in a clockwise direction, and we use compass directions a lot for this. So just to show you, north and south will be up and down on your page, but to make sure you have west and east correct, once it's spelling out we, then you know you have it in the correct order. So just keep that in mind for later on when you have to do your compass directions. So we start at north. North is normally the starting point, 0 degrees, and we always move in a clockwise direction. Clockwise means the direction the clock hands turn in. The clock hands go in this general right direction. They turn like this. Because remember, it's an angle, and an angle is a measure of turn. And just as a standard, we use 3 digits. So instead of seeing 35 degrees, you might see 035 degrees. And again, they use this a lot in travel. So from one country to the next, either by boat or by plane, because when you're on the road, you're making a whole set of zigzags. But by boat or by plane, they just basically turn their course and they're setting in one direction and flying a straight line, because that will be the shortest point. And obviously, they'll take more complicated things like wind speed or ocean currents if it's by boat into consideration. So let me start. So if north is 0 degrees, as we turn, by the time we reach east, east will be 90 degrees, and again they will stay 3 digits. And again, we keep turning about this central point here. South is really 180 degrees. And we keep turning, west will be 270 degrees, and by the time we reach back to our starting point, we cover the full circle, which is 360. So that's how the bearings would work. A lot of times, to see how this would work though, we have to make a sketch. Now a sketch means it doesn't have to be exact. We don't need the protractor to measure the angles. The topic we need the protractor for will be the geometric construction, which will be coming after this, which related to the TD topic for those all that are doing TD. So the bearing of B from A is 60 degrees, and I want to sketch this. So the bearing of B from A, so the English comes into it. From A means at A. If I'm calling you from home, that means I'm at home. So the first thing we're going to do is put a dot, and from A means at A. And what I have to do, I have to actually get my bearing. So to get my bearing, I need to do my starting point. And my starting point is north, which is 0 degrees. And I want to cover 60 degrees because that's the sketch. So I start turning from north. I know here is 90 degrees. Remember, it's just a sketch. So I just approximate 60. So we could say 60 is somewhere around here. Again, we're just approximating. That's why we call it a sketch. So B going to be somewhere in this general line here, and the angle inside here, that is my 060 degrees. That was the turn I make. And we do a sketch. The bearing of A from B is 60 degrees. Let's look at the next one. What if I wanted the bearing of X from Y is 315 degrees? So same thing, which point at? That's the first thing I want to know. Which point at, which point I want to go to. So from Y means at Y. And at Y, first thing I'm going to do is draw my north line. That's my starting point, 0 degrees, and I want to turn in a clockwise direction until I cover 315 degrees. So let me start. We at 0. By the time we reach here is 90, 180, 270. So I know 315 going to be somewhere in between here. I'm just doing a sketch. I'm going to do my sketch. Approximating that is there. X going to be somewhere on this line, and this going to be my big angle here. That's the turn at 315 degrees that I'm making, and as a result, this will come up later on. Inside here is just to finish off the circle, which is 360 take away 315. So if I wanted to use this or have anything about this, here going to be 45 degrees, because those math pieces going to come in eventually. So this is the sketcher. The 315 degrees, again this part not essential yet, but we're going to see that now in this next piece here. The bearing of B from A is 126 degrees. What will be the reverse? So I'm going from Barbados to Antigua, and that's the coordinate I fly on. What coordinate I need to fly, what angle I need to fly on, my bearing I need to fly on the return home from Antigua to Barbados. Right? So let me make a sketch of the first one and see what's taking place. So B from A, so at Antigua first. I draw my, I just give the A and the B two country names from the Caribbean, right? It's not really Antigua and Barbados. So this is point A from A, and I want to travel 126 degrees. So I start to turn 90, 180, so 126 somewhere inside here. So we say 126 is about there. And that was the first line of information. The bearing of B from A is 126 degrees. If I want the bearing of A from B, that means now we at B. Now we at B. And I want to go back to A. So obviously I can't use the same bearing because that'll make me further away. So now that I'm at B and I want to go back to A, first thing I have to do is draw my outline. And again, I could only move in a clockwise direction. I can't go this way. So I have to turn this way. So the big bearing that I need to go from B back to A, this is the bearing and that's the angle I need to find. How am I going to find that though? So if I realize that if I could find this, just like in the last one I was showing you, if I could find this angle, then I just minus this from 360 and I could get this one. But how am I going to find that angle as well? So we're doing, remember I said the application of geometry and trigonometry. So that means we have to use one of the geometry rules. And one of the things you should notice about knot lines in general, knot lines pointing in the same direction, they will never cross. And they even have arrows on them. So we could even say that, well, they are parallel, right? But the arrows could be like a reminder that those two lines parallel, even though the arrows wasn't to indicate they are parallel in this case. So these two lines parallel. How that going to help me though? Because I have rules with parallel lines. Which rules I'm going to use? So the three rules I have with my parallel lines, corresponding is top and bottom. That will apply here because we don't have a top and bottom. Alternate is a Z shape. I don't have a Z shape here either. So that means it has to be interior. So on the inside, this time my parallel lines running here. On the inside of the parallel lines, these two angles going to add up to 180. That was the rule with the parallel lines. So this side and this side is supposed to give me 180. Meaning, if he put up 126, he had to put up the rest. How much the rest going to be? 180 take away 126. And when I work that out, here going to be 54 degrees. Now 54 degrees is not my answer. I wanted the outside here. But now that I know here is 54 degrees, now I could find the remaining to make up 360. So inside here will be the 360 for the whole circle minus that 54. So the bearing of A from B, this big angle here, is going to be 306 degrees. So you're seeing how the geometry rule is going to come into play. Last example before we look at some past paper questions is, so this one was more with geometry. This one going to be with trigonometry now. So these are the trigonometry aspects of it. P is 12 kilometers due east of Q. You realize we have lengths now. The others didn't have length, it was just angles. So now we have some lengths. So P is 12 kilometers due east of Q. R is 8 kilometers due north of Q. And I have two things I want to find out. The distance of P from R and the bearing of P from R. So that means I have my point Q because everything happening around Q. And again, I'm going to just remind myself of the compass directions, north, south, west, and east. So 12 kilometers to the east of Q, so that's this way. So if I go 12 kilometers, again, it's just a sketch to help you with the diagram. So 12 kilometers to the east, I have my point P, and this distance here is 12 kilometers. And 8 kilometers due north, I have my point R. And because I went straight east and straight north, this is a 90-degree angle, which makes sense because I'm dealing with right angle triangles for now. Later on, when we do in section 2, we won't have right angle triangles. And we'll have different rules for those different types of triangles. So, I have my right angle triangle, and the first thing they want is the distance from P to R. So I have two sides of my right angle triangle. I want to find the third side. I have no angles yet. So what I could use to find that? So what is normally happen is, once students learn about trigonometry, sine, cosine, and tan, they tend to forget about Pythagoras. But we could use Pythagoras here because I have two sides. I want to find the third side. So for the distance of P from R, the hypotenuse squared will be the base squared plus the height squared. So this is my base, this is my height, this is my hypotenuse, which is what I want. So I put in my numbers. So it will be 12 squared plus 8 squared. 12 squared is 144 plus 8 squared is 64. So the hypotenuse squared, or PR squared if you want to call it that, will be 208. So the hypotenuse, running out of space, the hypotenuse will be square root of 208. Again, just to show it on my calculator here, everybody one might be slightly different. I have my square root button here. I press square root 208 and I get to one decimal place 14.4. Again, the question could state otherwise, but this will out to 14.4 kilometers this time. So the distance from here to here was 14.4 kilometers. That wasn't anything really new though. The new part is really the bearing. So the bearing of P from R means at R. The first thing I'm going to do at R is draw my north line. That's my starting point, and I want to turn until I hit the line with P. So that means I really want this angle here, and just from the sketch you could realize the angle is more than 90 degrees but less than 180. How am I going to find that though? Because I don't have any direct way to find it. However, I know this is a straight line here. If you notice, these are things you have to notice yourself. So this is a straight line. What you know about a straight line? A straight line, if it was completed, is 180. So if I could find this angle inside here, and we call it theta, then if I subtract 180 from theta from 180, I'm gonna get the balance, and that's the kind of roundabout, indirect way we find these angles. How am I gonna find this angle though? Well, since it's inside my right angle triangle, that means I could use one of my trig ratio rules. So this time I want to find an angle. I still label the sides though, so you realize the name's gonna change because now I'm gonna have opposite the angle. Now I'm still gonna have the hypotenuse, he don't change, and I have adjacent. So in this example, I have all three sides, but if I didn't figure this part out or they didn't ask for it, or I made a mistake with it, it's always safer to use what the question give you. So I would have used the 12 and 8 as opposed to the 14.4, just in case I made a mistake. If you had no choice but to use it, fine. If it's correct, well, you could use any ratio you want. But just to make it simpler, I'm just going to use these two, opposite and adjacent, which is tan. So for part 2, tan theta is equal to opposite over adjacent, but I want an angle, so theta would be tan inverse opposite over adjacent. And then I put in my numbers. The opposite side was 12, the adjacent is 8, so it's tan inverse 12 over 8. I want to put that in my calculator. Again, second function, tan inverse, open my bracket, 12 divided by 8, close my bracket. The angle work out to 56 degrees to the nearest whole number. But just like before, that's not my answer. That's the piece inside here work out to 56 degrees. I want the piece outside here to complete the 180, so it's going to be 180 minus 56 degrees, so my answer actually going to be 124 degrees. And you can see this getting into some of the harder sections of the topic, because you have not only the trigonometry part, but you have to know how to do the bearing part as well. So we'll try some past paper questions and see how we do with those after.